Welcome to The Explainer. Today, we're diving into some fascinating research from the Peer Computer Science Journal that totally flips a common idea about AI on its head.
When we think of a perfect AI, we usually picture this being of pure, cold logic, a kind of digital Spock that never gets it wrong. But what if that's not right? What if that's actually its biggest weakness? What if the real key to building a smarter, more adaptable AI isn't to get rid of emotion, but to actually build it in?
To really get why this is such a big deal, we've got to start with a core problem that stumps even the most powerful AIs. It's a problem that you see everywhere in the real world, from the stock market to diagnosing diseases.
So, researchers have a technical term for this. They call it a non-stationary environment. All that means is, it's a situation where the rules of the game are constantly changing on you. So what worked perfectly a second ago could suddenly become the absolute worst thing you could do.
Think about it like this. A standard AI is trained to be this incredible chess grandmaster. It knows every opening, every strategy, but what if, halfway through the game, the pawns suddenly start moving like queens? Well, that AI, it's going to get completely lost. Its whole system, its logic, was built for a world with stable rules. The moment you introduce chaos, it just falls apart.
So if that rigid logic doesn't work, where do we look for answers? Well, the inspiration might actually be inside our own heads. For millions of years, living things have been the undisputed champions of adapting to a constantly changing world.
This research from Kim and Kang basically suggests that we've been looking at emotions all wrong. They're not some bug in our logical software, no. They're nature's super-fast shortcuts, heuristics, for dealing with a world that never sits still. And our brains have this incredible toolkit for doing this on the fly. You've got your amygdala spotting a threat in as little as 70 milliseconds. That's way faster than you can even think. Then the hippocampus pulls up memories of how you felt in similar situations to guide you. It all gets mashed together in the prefrontal cortex, with dopamine chiming in to say, hey, that was surprising, pay attention. Yeah, it's messy, but man is it effective.
So, inspired by this biological blueprint, the researchers decided to try and build a completely new kind of AI, one that could copy that emotional advantage. Let's dig into how they actually did it.
They called it ECIA, which is short for Emotional Cognition Integration Architecture. And this diagram gives you a pretty good idea of how it works. See how the information from the outside world doesn't just go into one thinking part? Nope. It gets processed at the same time through an emotional pathway and a cognitive one, and then they're combined to decide on what to do next.
And what's so cool is how much this mirrors that brain toolkit we just talked about. It's got an external limbic system that acts like its emotional core. It has a dopamine learning module that gets all fired up by surprises, an episodic memory that works kind of like our hippocampus, and then a prefrontal decision unit to pull it all together.
So instead of just crunching the numbers, those cognitive signals you see on the left, ECIA also generates these 8 emotion-like signals. So if a reward suddenly drops off, it might trigger fear, telling it to back off. Or if things get boring, it might trigger curiosity to go explore something new. It's literally feeling its way through the problem.
All right, so having a cool architecture is one thing, but the real question is, does it actually work any better? Well, to test their creation, the researchers put it through this gauntlet of 3 very different challenges, each designed to test a specific kind of adaptability. First up, the sudden shock. Imagine this, for 100 rounds, there's one clear, obvious best choice. The AI learns it, gets comfortable, and then wham! In a single instant, that best choice becomes the absolute worst one, and a different option becomes the new best. The question is, how fast can it figure that out and adapt? Next up, they tried the exact opposite with the predictable loop. This isn't chaos, it's perfectly orderly. Every 40 rounds, the best choice flips from A to B and then back to A. It's a simple, rhythmic pattern. The question here is, can the AI see something simple for what it is and not overcomplicate things?
And for the grand finale, they threw the AI into the random storm. This is just pure chaos. The rules change at random times to random new rules, and just to make it even harder, the environment throws in these little fake signals, little blips of high reward that don't mean anything. This is the ultimate stress test.
Okay, so this is where it gets really, really fascinating. Because going into this, you'd probably expect the fancy new emotional AI to just dominate across the board, right? Well, that is not what happened. What they found was a really clear and surprising trade-off.
Okay, let's look at the random storm first, the chaotic one.
And here you can see the emotional ECI was the clear winner. It did way better than the standard logic-only AI, what they call the naive UCB. When things got messy, those emotional shortcuts paid off, big time.
But now, look what happens in the nice, simple, predictable loop. The results completely flipped. The more complex, smarter, emotional AI, it actually lost to the simpler algorithm. It was overthinking the problem. The researchers gave this a great name, the cost of complexity. It means that sometimes being too sophisticated is actually a disadvantage. All that emotional machinery that was so critical in the storm, it just got in the way when the pattern was simple. And this table just lays it all out, crystal clear. The emotional AI, ECA, dominates in the chaotic world, but the logical AI, the UCB, wins in the predictable one. This gets us to the really crucial point. The emotional system is a specialized tool. It gives you a huge advantage in uncertainty, but it actually becomes a bit of a burden when things are simple. This effect was so obvious they even identified what they called a dopamine paradox. The very system that was designed to help the AI learn faster from surprises, that dopamine-like system, was the same thing that made it overreact and perform worse when the world was stable and predictable.
So what in the world does all this mean for the future of AI? What's the big lesson from this fascinating trade-off?
Well, the goal here isn't to create AIs that get happy or sad. It's about building highly specialized tools that can survive and even thrive in the chaos of the real world. Think about an AI that can manage a financial portfolio during a market crash, or help a doctor make split-second decisions when a patient's condition is changing rapidly. Those are exactly the kinds of volatile environments where an emotional AI could be an absolute game changer.
And that leaves us with this really powerful question to think about. We just saw how emotion, something we often write off as a bug in human logic, can actually be a powerful feature for an AI. So, what else are we missing? What other so-called human flaws might actually be the secret ingredients we need to unlock the next generation of artificial intelligence?